Okay, today we are going to derive our last inverse trig function that we haven't derived yet, and that is arccot x. Well, the first thing that we're going to do is not that, we're going to do it with a pen, is to let arccot x equal y. Because then we can look at the inverse relationship, which states that cotangent y equals x, and we can use that to derive our trig function, our inverse trig function implicitly. With implicit differentiation, what we want to do is we want to differentiate each side of the equation separately. So we're going to write d by dx of cotangent y equals d by dx of x. Well, let's just note that we have a variable mismatch here. So what does that mean? That means we need to use the chain rule. So we have cotangent y is going to be a composite function, isn't it, of cotangent x composed with y. So our outer function, f of x, in f and g notation, is cotangent x. And the derivative of cotangent x is negative cosecant x squared. And then the inner function, g of x, is y. And the derivative of that is dy by dx, which is our slope of the tangent line. Slope of the tangent line. That is what we're solving for. And that is not a division, mind you. That is the change in y over the change in x. So the next thing that we're going to do is we're going to just apply all this to the chain rule. Well, the chain rule, if you remember, of f composed with g of x prime is f prime of g of x times g prime of x. Well, we have everything we need to complete that already. And so we're just gonna plug all of that in. So we're gonna plug in negative cosecant y squared, because here we have our inner function, and negative cosecant squared is our outer function differentiated, times dy by dx equals 1, because x differentiated with respect to x is just 1. And it makes sense because when you think what's the change in x over the change in x, well, that is something over itself, and that's always 1. Okay, so now we're going to divide by negative cosecant squared y, and we are going to end up with dy by dx is negative 1 over cosecant y squared. Well, now how do we get rid of this y? Because we don't want the y in the denominator. We want an x in the denominator, right? Because we need to go back to our former notation. Well, let's go back to the beginning. Cotangent y is x, which is x over 1, because anything is itself over 1. But it also is adjacent over opposite. Because it's a reciprocal of tan, we can just think, oh, what's tan? Tan is opposite over adjacent. So cotan is adjacent over opposite. We just flip it. Well, we can make a little triangle here, and we can label the sides, because we have two sides of a right triangle here and an angle y. If this is our angle y right here, and this is 90 degrees, then we know that the adjacent of that angle is x, and the opposite is 1, and therefore the length that we don't have is x squared plus 1 squared, which is x squared plus 1, but in a root, because the formula is a squared plus b squared equals c squared. So if you want to get one of those, you need to take the root of the other two. So what I did here, because these are a and b, 1 squared plus x squared equals something we don't know squared, I just took the root of them. So that's how I got that length. Okay, so now what do we have? Now we have cosecant squared y in the denominator, though. Well, that's not cotangent y, but we know that cosecant y is the reciprocal of sine y. We know that sine y is opposite over hypotenuse. Therefore, cosecant is hypotenuse over opposite, which is the root of x squared plus 1 over 1, which makes it just itself. Well, we can just plug that in. So our solution is going to be dy by dx is the derivative of arc cotangent of x is negative 1 over the square root of x squared plus 1 squared. And the reason we're pulling that square out is because of the power rule. This one right here, I'm just gonna write it down for you in case you've forgotten. You can just pull that exponent out, or you can put the exponent in both the denominator and the numerator. In this particular case, I pulled it out. Well, 1 squared is just 1. So we're going to end up with negative 1 over x squared plus 1, which, if you remember, is just the negative version of the derivative of arc tangent x. And that is our solution.